I'm Abby. I'm a third-year biomechanical engineering student. So the way that Merlin is currently structured is that we have three main technical teams. We have one team focused on brain-computer interface application development, which is currently working on a video game. We have one team which is focused on software development, which is currently working on back-end code of two separate APIs. One is called BLE2LSL and one is called LizardHat. And we have a hardware team which is currently focused on the design of a PCB board. One of the main goals of Merlin Neurotech is to expand the amount of students that we have working with this technology who understand how it works. One way that we do this is through our brain-computer interface application team, where we have students developing both a front-end GUI as well as AI to process the data that we've collected. This allows new students coming into the field to learn a bit more of a basic side of the coding while still getting involved in the field and understanding how it can be directly applied.
Hey, my name is Sean. I'm the director of the BCI team at Merlin Neurotech. I'm in my second year of biomedical electrical engineering with a focus on machine learning and artificial intelligence. I joined because I think BCIs are kind of the next step towards understanding the brain. We have theories about how the universe began, but we still have organs in our bodies that we don't know the origin. And the brain is one of those things. It's one of the great mysteries of the world, and I think it's kind of the next frontier. So the project we chose this year was to create a binary classifier between concentration and relaxed EEG signals. And essentially what this allows us to do is use that classifier as a binary controller. And as you can imagine, binary controllers are super versatile and can be used in a ton of different applications. So what we decided to do for this year was just create a simple GUI with a balloon that essentially is floating above some spikes. And when the machine learning algorithm detects that somebody's concentrating via their EEG signals, the balloon begins to float upwards and away from the spikes. So something that really helped us through our project development this year was sort of all the different backgrounds that we had in our team. We had a bunch of different people from a bunch of different programs, all contributing knowledge from different fields. And that really helped with all the different aspects of the project we had this year. So we decided to split people off based on interest and technical ability. We had people collecting data for our project, and we also had people working on the digital signal processing, and then we had people working on the neural networks and just the machine learning aspect, and then one person dedicated towards working on the GUI at the end.
Hi, my name is Beatrice, and I'm third year life science in neuroscience specialization. I joined Merlin Neurotech this year because I'm interested in the application of neurotechnology in clinical application of curing disease such as Parkinson's or Alzheimer's disease. Our team decided to develop a brain-computer interface by training an AI model that can differentiate between concentration and focus or relaxed data. And I decided to get involved in the data collection side of this because I used to running clinical studies on mouse models, and I wanted to see how it applies to human participants. While trying to train an AI and collect some human participants, we ran into a lot of problems, and one of them was participants being very scared of what we're going to use their data for, and they're scared that we could discover stuff like their IQ or their intelligence by running this EEG, which is not the case. And another problem we ran into was the model not being efficient enough to distinguish between the focus and relaxed data. To overcome these struggles, we had to explain to people that EEG signals are anonymous, and that we're not getting any other data other than focus or relax and their eye movement from the EEG signals we're collecting.
Hey guys, my name is Shreyansh Anand, and I'm in biomedical computing in second year right now. And the reason why I joined Merlin this year was because I want to explore how we can expand the future of human-computer interfaces. So we started off by using the Muse data and then using different filters on the data so we can then see exactly how concentration works and see when someone's concentrating. After all the data is filtered, we implemented a game where it will cause the object to move when someone concentrates and will not move when someone doesn't concentrate. So before joining Merlin, I've had a few years of programming experience, but I had no idea anything about machine learning or AI or anything like that. So when I joined Merlin this year, I learned a lot more about the pre-processing, for example, and more of just how we can exactly use different AI algorithms to work on the brain-computer interface idea. So this year I focused more on the pre-processing and was able to get the data set up so we can use it on our neural networks in the future and also work on an implementable basic interface. So the game is rather simple. The idea is that it is a balloon which goes down and falls down towards a set of spikes at the very bottom. However, when you concentrate and think, it will start to rise up, and the goal is to keep the balloon afloat for as long as possible.